Scatter Plots in Line of Best Fit Notes by Lily Gavin, Max Brewster, Hannah Larasby, and Maddie Landisberg. Today's objective is to learn how to calculate scatter plots in line of best fit while using corresponding data. A scatter plot has points that show the relationship between two sets of data. Data with two sets of variables are called bivariate data. Scatter plots have three different correlations, and the three different correlations are positive, negative, and no correlation. So basically what we're looking at is this is positive. If it was negative, it would be going down, and if it had no correlation, there would be dots all over the place, so it wouldn't look like anything. Now, to talk about line of best fit, a line of best fit, LBF, is a straight line drawn through the center group of data points plotted on a scatter plot. Scatter plots depict the results of the gathering data on two variables. Sorry for the handwriting, by the way. It is a lot harder than it looks to write on this app. So now we're going to go a little bit more into depth about the three different types of correlations. So the first one that we have, positive correlation, is the points lie close to a straight line, which has a positive gradient. So you see that all the points are going up instead of down. This shows that as one variable increases, the other increases, so both increase at the same time. Negative correlation, which is this one, is the points lie close to a straight line, which has a negative gradient, going down like this. This shows that as one variable increases, the other decreases. So as one increases, this is going to go down. For no correlation, there is no pattern to the points. So as you can see, there's all over the place. You can't really make a line. There's nothing that can show any type of correlation. And this shows that there is no connection between two variables. So between these two things, there is no connection between either. So we're going to start out with the first problem, which is this one right here. So I'm going to draw a line.
Okay, so let's just read this problem out. The scatter plot shows the number of CDs that were sold from 1999 to 2005. If the trend continued, about how many CDs were sold in 2006. So as we can see here, in 1999, about, let's say, 940 CDs were sold. So in 1999 equals about 940 CDs. Sorry about the handwriting. And then in 2006, 2005 rather, we could see that there are about 700 CDs sold. So 2005, 700 CDs. So basically, we're just going to look at the data and we're going to draw a line of best fit. And we're going to see right here that it's basically a line of negative correlation. And we can look and see that the line basically ends up right around here. So now a good tip that we think that will help all of you when you're doing line of best fit is to show that the year, let's make 2006 over here. And we can show that the data just falls right around there. Sorry if this is a little bit confusing. The shapes are just so hard. Anyway, so based on the trends that the line is showing, is that the data is slowly falling from 1999 to 2005. And you can see that the data is just so close together that you can make somewhat of a guesstimate that 2006 is equal to about, let's say, 600 to 660. Let's just decide on a number, 650. And that's your answer. So the first thing we're going to do for this problem is establish the 2 points. So for our first point, it is up 6 and over 8. Our next point is up 0 over 2. So now you're going to do the slope formula, which is y2 minus y1 divided by x2 and minus x1. So it's 6 minus 0 and 8 minus 2, which equals 6 over 6, which equals 1 over 1. So now you have to plug it into y equals mx plus b. So it's going to be 6 equals 1 times 8 plus b. And now we have to solve for b. And we subtract 8 from 6, which is negative 2. So b equals negative 2. And now all you have to do is y is equal to x minus 2. And that's your final answer.
Alright, so for this problem, the table below gives the height and shoe sizes of 6 randomly selected men. The two factors we have here are height and shoe size. If a man has a shoe size of 10.5, what would be his predicted height? So for this, we're basically going to have to find the scatter plot showing the amount of sleep. Alright, so my 2 points that I have chosen are 67 over 8.5 and 75 over 12. So let me write that over here. And 75 over 12. Alright, so I'm going to put these in coordinate form. So I will put 67 for the height and 8.5 for the shoe size. And then the other is 75 for the height and 12 for the shoe size. Alright, so what we're going to do is write the equation out. y2 minus y1 over x2 minus x1. And we have to put our points here that we want to plug in. 65 and 8.5 and 75 and 12. Let's actually put blue. Alright, so let's write this out as an equation. We'll do 12 minus 8.5 over 75 minus 67. Then, once you subtract those two, you're going to get 3.5 over 8. Alright, so we will have to plug this into our equation of y equals mx plus b. So, let me erase this first so we have more room. Alright, so we will just write down our y will be 8.5 and then equals 3.
Maddie, the autograph pages are within the
8.
So like there's one for sports.
And then our x is 67.
No one wants you here. Me.
Let me just move over here. And then plus b, which is what we're going to have to find. So from here, so we get 234. Alright, so the equation will now look like this.
It took me like 20 minutes to download
Then our equation will look like this.
Lily's not ugly. You look like the model that he wanted to do.
Alright, so then from there, our b will equal 3.45. From there, we'll set up our new equation, which is y equals 67 plus 3.45. So our answer will be height expected is 70.45 for our answer.
To finish off our lesson, we're going to do an easy problem about correlations. This is a scatter plot showing the amount of sleep by day per age. As you can see, as you grow older, you need less sleep, still probably more than you are currently getting. Haha, that's funny. What type of correlation is shown here? So, if you can remember from our past notes, we showed different types of correlation. There's positive correlation, which goes up like this. No correlation, which is just random, and negative correlation, which goes down like that. So obviously what we see here is that this goes down in a negative correlation. So the line of best fit and this type of correlation would definitely be considered a negative correlation.
Yeah. So you know, it could just be like,
Wait, is it almost done?
oh, Abby's just in your costume.
And that is going to be your final answer. Thanks for watching our video notes. I hope it helped you with scatter plots. If you have any questions, please let us know. I know that this video can be a little bit confusing because we don't always know exactly what we're doing. But I hope this helped you. Thanks.
Yeah, Maddie.